So, welcome to my tutorial. So today we solve the problem of that is XOR problem. Sum of XOR of all pairs, right? So this problem says that given an integer array of size n, compute the sum of the bitwise XOR for all distinct pairs of elements. That is, consider every pair of indices I, j such that 0, I, j and n, and calculate the total sum of array of I XOR array of j over all such pairs, right? So in that, the problem is we have the array of I, array like 7 and 3 and 5. Now we just have to take and find the total sum I and j overall all such pair. All pairs we have to like 7 3, then 7 5, then 3 5, and then we just have to calculate the total sum, XOR sum. So first we get the 4, and then 2, 4 to 6, and 6 6 12. So that is the 12 answer. So that is the problem. So in that, in the naive approach, that means brute force approach, what is, check every pair I and j and compute array of I XOR array of j, right? That is very simple, like here, and then int n is equal to array dot size, right? And then int sum is equal to 0. Now for int I is equal to 0 to start to n and I plus plus, right? Now for int j is equal to I plus 1 to j is equal to n and j plus plus, right? Now sum plus is equal to array of I XOR of array of j, that is right. And now return sum. So now check it will run or not. Yeah, it will run, but yes, it will give the TLE. Why? Because it will take the order of n square time complexity, right? Space is order of 1 because I will not use any speed, but yes, time is used to the order of n square, right? So what we can do in a better approach is bit manipulation thinking, right? How? So bit manipulations means instead of comparing pairs, focus on each bit independently. Like currently we just have to currently we just have to compute the every pair, right? So in that, bit manipulation thing is focus on each bit independently, right? For XOR, a bit contributes 1 only if bits are different, right? The bits contribute 1 only if bits are different. So for each bit position, count how many numbers have bit is equal to 1 and count how many number have bit is equal to 0, right? So count 1 is equal to number of element with the bit is equal to 1, and count 0 is equal to n minus count 1, right? So that is, so number of pairs where XOR gives 1 at this bit, right? So that is the, so and that is also the good one, but we are not write the optimal coach, and optimal coach also contribute of this better in that contributes of this, count 1 into count 0 into 1, uh, then left what is this is the yeah. So in that, so we just have to count the optimal approach. What is the optimal approach? Algorithms loop over bits 0 to 31 count. And what is the optimal approach? What you can think as an optimal approach? So as an optimal approach, we just think loop over bit 0 to 31, count 1, and add to result. So in that, the time is we just have to loop for the 31 till 31. So here now I just write the optimal approach, right? So from the optimal, I just start from here, right? And in that place we use the long, and instead of sum we just have to total sum, right? Now 4 int bit is equal to 0 and bit equal to 32 and bit plus plus, and then long and 1 is equal to 0 for int I is equal to 0 and n is equal to n and I plus plus, right? Now if array of I and 1 now bit, then count plus plus, right? And then just long count 0 is equal to n minus count 1, right? And then long pairs is equal to count 1 multiplication of count 0, right? So now so total sum pairs into 1 ll 2 bit return total sum. Now I check count plus plus. Oh, in that count 1 plus plus, that is my bad. Now check, yes, it will pass all the test cases or not. Yes, it will pass the all test cases. So in that the time complexity is very simple, order of 32 into n, so order of n, and space is order of 1. That is, so this is the problem solution. So make sure you like, and please make sure to like and subscribe my channel. Thank you so much.